Problem number 3. Find the missing angle. Well, this is very easy. We know that all three angles add up to 180. If you add 42 and 26, you get 68. And all you would have to do is subtract that from 180, and you will get 112 degrees. Similarly, in letter B, 118 plus 16 is 134. And if you subtract that from 180, you get 46 degrees. Problem 4, same two triangles here. Let's fill in the angles we found. This was 112, and this was 46. And we are being asked to list the sides from smallest to largest. Well, the smallest side is opposite the smallest angle, and so forth. So in letter A, the smallest angle is 26 degrees, which means the smallest side is side A. The medium angle is 42 degrees, so the medium side is side C, followed, of course, by the largest side, side B. In the second triangle, the smallest angle is 16 degrees, so the smallest side is C because it's opposite the 16 degrees. A is opposite the medium angle, and B is opposite the big angle. Problem number 5, the triangle inequality. This states that the sum of the lengths of any two sides must be greater than the third side. So someone is claiming that these three numbers are the lengths of the three sides of a triangle. We want to see if that's possible. You just have to check three things each time. 3 plus 4, is that bigger than 5? Yes. 3 plus 5, is that bigger than 4? Yes, it is. 4 plus 5, is that bigger than 3? Yes. Therefore, this is a triangle. We want to circle the ones that would not make a triangle. How about 6, 7, and 10? Again, just check those three things. 6 plus 7, yes, bigger than 10. 6 plus 10 is obviously going to work. 7 plus 10 is bigger than 6, so that one's just fine. Aha, here's one that doesn't work. 3 plus 5 is 8, and 8 is not bigger than 12. So you cannot have a triangle with sides of 3, 5, and 12. The idea is if this was a 12, and then you had a 3 hanging off of here, there's no way that with a 5 you can reach all the way down to where you need to reach. It just isn't going to work. You can't have 3, 5, and 12. So that set does not make a triangle. How about 5, 12, 12? Well, 5 plus 12 is bigger than 12. The other 5 plus 12 is bigger than 12. 12 plus 12 is obviously bigger than 5, so that's fine. Here's one that is bad again. 2 plus 7 is equal to 9. That's not enough. It has to be greater than that third side. So 2 plus 7 is equal to 9. This cannot be a triangle. I always think of this as simply the shortest distance between 2 points is a straight line. I mean, if this total distance is 9, from here to here would be 2, and from here to here maybe would be 7. Well, you couldn't make a triangle out of those pieces because you'd automatically be traveling a greater distance than 9. How about 4, 10, and 13? 4 plus 10, yep, that barely makes it. And 4 plus 13 is fine, and of course 10 plus 13 is fine. So only the third set and the fifth set had problems. Problem number 6, let's apply this in a different way. So I've filled in the shortest side, and I've filled in the longest side. So you know that this other side is somewhere between 4 and 11. We're trying to fill in some possible values. Well, remember, this triangle inequality has to apply. So could I put a 5 right here? I could not, because 4 plus 5 would be too small. It doesn't make 11. Even 7 would be too small. That would just equal 11. I could use 8, though. 4 plus 8 would work. 4 plus 9 would work. 4 plus 10 would work. And of course I could use 9.5 or 8.3. These are just the simplest numbers that I could use. How about in the second example? Again, this is the shortest side, this is the longest side. Even 28 would be too short because 20 plus 28 equals 48, but past 28 I'm going to get numbers that work. So numbers like 29 or 30 or 31. I think I could go all the way even up to 47 and still have an answer that worked.